Okay, we are in case 2, and this is the sample. Okay, so the way that we do it is exactly the same as we used to do. Now we have y1 and y2. So first we got to assume the answer of our y1 and y2. y1 is equal to k1 times exponential of lambda t, and y2 is equal to k2 times exponential of lambda t. And then, since our differential equation, we have the first derivative of y1 with t and the first derivative of y2 with t. So we got to do differential of our assumption. So we got dy1 by dt is equal to k1 times lambda times exponential of lambda t. And the first derivative of our y2 by dt is equal to k2 times lambda times exponential of lambda t. And then we just plug everything that we assume and the result of our differential back into our linear system. So we would get k1 times lambda times exponential of lambda t is equal to k1 times exponential of lambda t plus 2k2 times exponential of lambda t. Our second equation, we will get k2 times lambda times exponential of lambda t, which is equal to minus 2 times k1 times exponential of lambda t, minus 3 times k2 times exponential of lambda t. 1 and 2. Both equation 1 and equation 2 will have term of exponential of lambda t, so it says that divide equation 1 and 2 with exponential of lambda t. So we would get k1 lambda equal to k1 plus 2k2, k2 lambda equal to minus 2k2, minus 2k1 minus 3k2. We just arrange these two equations in such a way that we put k1 and k2 to k2. So we would get 1 minus lambda k1 plus 2k2 equal to 0. Take it as the equation 3. And the other equation is just that minus 2k1 minus 3 plus lambda k2 equal to 0, which is equation 4. From this 3 and 4, we can write out our characteristic equation. Which is the determinant of 1 minus lambda 2 minus 2 minus 3 plus lambda equal to 0. And then we do the determinant. We would get plus 4 equal to 0. So we get lambda square minus 3 plus 1 minus 2 plus 2 lambda minus 3 plus 4. So we got two values of lambda, which is, so lambda is equal to minus 1, which is the real repeated root. So now our answer got to be in the second case. And in the second case, we got to be able to find the beta value. Okay. So in order to find that, we got to find beta by using the correlation that I just get to use, saying that a minus lambda I times time beta is equal to k. A minus lambda I, A minus lambda I is equal to this term, equal to this characteristic equation is our function for the characteristic equation. So I would like it this way. And then we need to find beta. Now we have two beta, beta 1 and beta 2, and K1 and K2. So in order to find beta, you got to know lambda and K. So now we have one lambda. So I said that put lambda equal to minus 1 into equation 3. From that we would get correlation between K1 and K2. So we would have 2K1 plus 2K2 equal to 0. K1 equal to minus K2. So we assume that K1 equal to 1, so K2 equal to minus 1. And then we put K1 and K2 into this correlation that we are going to find beta. And here we know our lambda, right? Our lambda is equal to minus 1. So we would get another set of matrix which is 2, 2, minus 2. Lambda is equal to minus 1. So this is minus 2, right? And then we got beta 1 and beta 2, which is equal to, our K1 is equal to 1 and K2 equal to minus 1. From this matrix, we said that the first equation is 2 beta 1 plus 2 beta 2 equal to 1. And the second equation saying that minus 2 beta 1 minus 2 beta 2 is equal to minus 1. So if you see these two equations are the same, so in that case I would say that beta 1 plus beta 2 is equal to 1 over 2. So if I assume beta 2 is equal to 0, then our beta 1 is equal to 1 over 2. Okay. So I said that the first set of the solution is y1, y2 is equal to c1. This one is k, right? If you remember here, c1 times k. We have 2k, which is k1 and k2. Our k1 is equal to 1 and our k2 is equal to minus 1. So the first set we would get 1 minus 1 exponential of minus t. And our second set is it is in the form of kt plus beta times exponential of lambda t, and we know that our lambda is equal to minus 1. We know our k and we know our beta. So now the second set we would say that y1, y2 is equal to c2, right, times k1 t beta 1. K1 is equal to 1, so we would get t, and this is beta 1. Beta 1 is equal to 1 half. This k is k2. K2 is equal to minus 1. Beta 2 is equal to 0. So we would get minus t. That is our second set. So the general solution of this linear system is the summation of the first set of the solution and the second set of solution, which is C1 times that's the answer.